Alrighty. So once again, warm it up here. If f of x equals 7x minus 3, find f of negative 2. How'd you do it?
Fill in negative 2 for x.
Yeah, okay. We're plugging in negative 2 everywhere where we see the letter x. Okay, so how that's going to look. I see x right here. I see x right here. Right? Okay, and now I'm just going to evaluate that, okay? On that left side, f of negative 2, there's nothing to do there, right? That's just the notation, okay? So don't get confused by that, okay? The right side is what I'm actually evaluating. How would I do that? Yes, Ava?
Multiply 7 by negative 2.
Yep.
And then subtract by 3.
Good, okay? And what is 7 times negative 2? Negative 14. And this gives me negative 17. So you're telling me that f of negative 2 equals negative 17, and that would be my answer, right?
Yes.
Okay. Any questions on that? Are we all okay with that? Okay. Cool. Awesome. How did we know to multiply the 7 and negative 2 together before we did the 3? Yeah, what I heard it. Order of operations, right? Parentheses. They come first, okay? Remember that acronym PEMDAS, or please excuse my dear Aunt Sally, whatever your Algebra 1 teacher called it, okay? We have to follow that. That's still a thing in Algebra 2 and moving forward, okay? Real quick, just hypothetical question. You don't have to write this down, okay? If I change this problem around a little bit, okay? What if I made this 7x squared minus 3. Would that change? It obviously would change something about this. I would put a squared on the negative 2, okay? But how would that change this as far as solving it, evaluating it? What would I do first? Would I multiply the 7 with the negative 2 first still? No? You're telling me to do the exponent first, right? Okay. So that's one thing that a lot of people get confused on, a common error that I see, because they're like, oh, well, parentheses come before exponents, right? Okay. Not when the parentheses are being taken to an exponent, okay? That's still evaluating parentheses. So if I had a problem like this, I would square that negative 2 first. What does squaring mean? Times it by itself. So what is negative 2 times negative 2? 4, so this would just become 7 times 4 minus 3, which would be 25. Totally different answer, right? Okay, so we can see how something as small as just a little power of 2 can change the whole answer of a problem. So just be careful with that if you see it, okay? Any questions on that? You might see that again today. Okay, so going off of that, number 2, it's asked me to simplify this. 2x minus 3 squared. Anybody think they got it? What did you do?
I multiplied it. I used the exponent, and it becomes 2x squared plus 9.
Okay, another common error. Thank you for your answer, but that's not correct. What did we just say squaring meant to do? Multiply it by itself. Okay, so if I'm squaring that whole binomial, okay, we call it a binomial because it's 2 terms being added or subtracted. Wouldn't it be this instead? You with me? We seen that? Okay, another thing from Algebra 1 that a lot of students mess up on. Okay, I did this on purpose. I wanted to stump you, okay? But yeah, anytime I have a binomial being squared, I am multiplying it by itself. This process is now called, starts with an F. I heard it. Foiling, yeah, fun stuff, right? Okay, so let's see if we remember how to do that. I'll go slow. First times first.
4x.
4x
4x.
squared, yay, okay. Okay, another thing from Algebra 1. When we multiply the coefficients, right? So 2 times 2 gives me 4. We are also multiplying the variables. When we multiply variables, if they're the same variable, we can add the exponents, okay? So since these are the same letter of the alphabet, they're both x. This is x to the first. This is also x to the first. 1 plus 1 gives me 2. Okay, that's how I get that power there. You with me? Yeah? This coming back to us now? Okay. Same thing here, 2x times negative 3. What's that give me? Negative 6.
Oh wait, we're adding. I'm so sorry.
X. Okay. Okay, so when we multiply, no, we're still multiplying the numbers, right? Okay. We're just adding the powers of the variables. And again, they have to be the same variable. No, you're okay. You're okay. Okay. Now we're done with that first 2x, okay? It's gone. It's already gone to everything it needs to go to. Now I'm going to deal with this negative 3. Negative 3 times 2x gives me negative 6x again. Good. And negative 3 times negative 3 is 9. 2 negatives make a positive. Okay. Am I done? No, why not? I still have to combine like terms. You guys are good, okay? What are my like terms here? Okay. Why is 4x squared not a like term with them? It has an x. Because it's squared, right? Okay. Can't trick you. X squared and x are not like terms, okay? They got to be the same letter of the alphabet, yes, but they also have to have the same power on them as well, okay? When we combine like terms, do we add the powers of the variables? No, we only do that when we multiply, right? When we are adding, we are only adding coefficients. So what do those become when I put them together? Negative 12x. Don't you dare put negative 12x squared. I will rip up your test. No, I'm kidding. I won't do that. Okay. Is this the right order that I wanted this in? Yes. Okay. If I put it like this, am I wrong? Yes. Not necessarily. It's still the same thing, but yes, I would take points off because this is an honors class. Okay. I want it in what we call descending order, meaning the highest power comes first. Everything follows from there. You with me? Yes. Okay. All right. So this is what we want. This is not what we want. What questions do we have? Are we feeling warmed up? No? Okay. Well, I hope you're lying. Okay. We're going to go ahead in next page. Okay. Learning targets for today. Looking up here, okay? Up here on my board is where I post all these learning targets, okay? Day 1, I can identify, represent, and evaluate functions using tables, graphs, mapping diagrams, and ordered pairs, including one-to-one and piecewise functions. All right, here we go. Introduction to functions, okay? So, functions. What I need you to know about functions. They have no repeating x values. Write that down. A function has no repeating x values. Okay. Functions for Algebra 2, we display them 4 ways. Okay. We display them as coordinate points, tables, mapping diagrams, and graphs. Okay. These are the 4 things we're going to see a lot this year, especially tables and graphs. Okay. If I look at this example that I gave you, okay, I got the points 2, 1, 4, 1, and 5, 2. Is this a function? Yes, why? Yeah, none of these x values repeat. I got 2, 4, and 5. I'm all good. None of those repeated, okay? I should have given you different examples for these other types, but it's actually the same example. So if I look at the table, same thing, just looking in that x column, okay? If I look at the mapping diagram, these are unique because they're kind of like a table, right? Okay, they've got the x's on the left, the y's on the right. Okay, that's always how mapping diagrams work. Except for I don't have to rewrite repeating numbers, okay? And I do need to write the numbers in order, okay? And then I draw a line as far as what points go together, okay? So we can see the point 2, 1 has an arrow from the 2 to the 1, okay? That actually looks like a negative 1, but whatever. 4, 1, and then 5, 2, okay? That's how a mapping diagram works. So you're not going to see those very often, but in the event that you did, that's how you read them, okay? And then obviously a graph just has those 3 points plotted, okay? Cool. Any questions on that? Okay, so quickly, let's talk about what wouldn't be a function. Give me 3 coordinate points that would not be a function. Okay, 1, 3, 1, 7, 2, 8. I love it. And why is that not a function? Repeating x values. What repeated? The 1. Okay, perfect. So now I'll go put those in a table. Now we're going to put it in a mapping diagram. Since that 1 repeats for the x's, I'm only going to write it one time. And then I'm going to go graph all of those. We're just sketching, so if your graph's not perfect, that's okay. So again, function, here's just the fancier definition, okay? A relationship where each domain is used exactly one time. Friends, when I say the word domain, and I'm going to say it a lot this year, okay? All I'm talking about when I say domain is your x values. Okay, that's what I mean by domain. So again, a relationship where each domain is used exactly one time. Domain is x values. What do you think the range is? The y values. Hopefully you've heard that as well. Okay. When we talk about domain, again, it's x values. So it's always going to be denoted as x. When we talk about range, it's going to be denoted as y or f of x, okay? I need you to understand this. F of x and y are identical, okay? They are the exact same thing. Exact same thing. So if I see a line that says f of x equals x plus 2, that's just y equals x plus 2, okay? So don't let that confuse you. F of x is just a fancy way of saying y, okay? Vertical line test, okay? Just couple more definitions here, okay? Vertical line test. This only works for graphs. But basically what the vertical line test is if I draw a vertical line through any point on a graph, if it only touches in one place, then yes, it's a function, okay? If it touches in more than one place, then it can't be a function, okay? Which makes sense, because if I look here at what was a function, right? If I drew a vertical line through any of these points, it's only hitting that graph one time, right? Okay, but if I go down here and I draw a line right here where I stacked those points, well, now it's hitting twice, okay? So it can't be a function. Does that make sense? Okay, so that's all that the vertical line test is. I am going to write out a big long definition there just to say that I did, but if you understand that, you don't necessarily have to write this out, okay? So it only works for graphs, okay? When I draw a vertical line through the graph, if it only hits once everywhere, it is a function. If it hits more than once anywhere, not a function. Writing it out just to say that I did. This video will get posted on Canvas, so if you ever need to refer back to this, you can. And then lastly, a one-to-one function. This one is important, okay? One-to-one means no repeating x values, but also no repeating y values. Okay, we call it one-to-one because it's 1x to 1y. Okay, that one makes sense, right? So no repeating x's. And no repeating y's. Beautiful. Okay, gonna test you. Work with your group here, okay? A, B, C, D. Are the following relations functions? Say yes or no. And then if it is it a one-to-one function? Yes or no, okay? One thing too that I forgot to mention. If something's gonna be one-to-one, right, it has to be a function before it can be a one-to-one function, right? Okay? I can't just become a nurse practitioner without becoming a nurse, okay? So just make sure you understand that. If something's not a function, it cannot be a one-to-one function, okay? Because it's not a function. Okay, try those out. Okay. Gentlemen over here, what are we thinking on A?
It is a function.
Okay, yes, it's a function. We all agree with that? Okay, no repeating x values, good. Is it one-to-one?
No.
No, why not? Yeah. Okay, yep, C repeated. C was a y value. Love it. Okay. Ladies in the middle, what do we think on B? Yes, it's a function. Okay, no repeating x values. Is it one-to-one? No? Okay, why not? There's repeating y values, okay? So it is a function because it passes the vertical line test, right? Okay. Do you think there's a line test we could make up for finding out if it's one-to-one then? Ooh, we just made that up. Look at us, okay? Mathematicians in this room. If I do a horizontal line test on it, because again, it passed the vertical line test, so that means it's okay to check for one-to-one. It does not pass the horizontal line test, so this would definitely not be one-to-one. Okay, yes, it's a function. No, it's not one-to-one. I'm going to write down here, horizontal line test can check for one-to-one. Okay, cool. Ladies back here, what are we thinking on C? Not a function. So therefore, can it be one-to-one? No, it cannot. Okay. Cannot. And gentlemen right here, what are we thinking on D? No. Okay, why not? The 2 repeated, right? Okay. Good. Any questions on this? Okay, hopefully you thought this was pretty straightforward. Let me know if you do have a question on it. Don't be shy, okay? This is kind of like the warm-up that we just did. So again, I'm going to let you work with your table here. I want you to do 1 and 2, finding f of 5 and g of -3.
That's close
Right.
enough.
Here you go, Ava.
Same difference. Right.
It
Okay.
is recording, no pressure.
Oh.
You got this.
You got this.
Hey, can they hear us?
Yeah. Is that okay?
Yeah, that's fine.
That's why she said no fussing.
Ooh. Whew. Sorry, I turned into
I
an
think I
owl.
had perfect attendance today, though, so no one this year will hopefully hear it. It'll just-
Now I'm scared I'm wrong. But I think I'm.
If you get this wrong, I'm gonna record it.
Stop!
Graduation.
No!
I'll put it up at
I
your
said if you get
graduation
it wrong,
party.
I'm gonna record it and then put it
Okay.
on.
Good job. Okay, so she plugged in 5. 3 times 5 minus 4 gives us 11. Awesome. Anybody want to do the second one? You do? Okay, good. Awesome. It's Annabelle, right?
Yes.
Okay, Annabelle's got us. We have -3.
Just gonna do the exact same thing. I have on my
Set a
paper.
record for me.
Okay. That's good. Embarrassing.
Okay, awesome. -13 was our answer. Okay. She was able to do that whole first step kind of in her head. She didn't write it down, but just make sure that we know that the -3 got squared and then multiplied by -2. That's where that -18 came from. Great job. Okay. Any questions on these two problems? Do we feel good about this? How to evaluate a number? Okay. The next big thing, and I really need you to pay attention to this, okay? Because this is where, honestly, I think that this is one of the ugliest sections of math we do all year. Why do we do it on day 1? I'm not really sure, okay? But I do need you to pay attention. So I'll wait a second. Wait for everyone to lock in. My table back there. Okay, operations with functions. Okay, we have been used to the 4 operations of math since elementary school, right? We know we got addition, subtraction, multiplication, division, okay? We can do this with functions, okay? But here's the issue that I have with it, okay? For some odd reason, in Algebra 2, we like to give you stuff in really ugly notations, okay? Just so that way we can try to confuse you, right? Okay? I need you this year to be able to read through those notations, to be able to realize that, hey, this is not as crazy as it looks. I just need to know how to write it better, okay? So when I look at this, f plus g in parentheses of x, that looks really confusing to me. It looks like I'm multiplying something when really that's not what's going on here, okay? What this means is, hey, this is one of my 4 operations because I see a plus sign between these 2 letters, right? Okay? And what that means for me is I'm allowed to break this apart. And that's exactly what I want you to learn to do, okay? So if you see something like this, just know that, hey, since these letters are being added, I can actually break these apart. This is the exact same thing as f of x plus g of x, right? And now if I look at that, okay, that looks a little better to me, right? That tells me what I'm actually going to be doing here, okay? Same thing with subtraction. It looks identical with a minus sign between. Okay, same thing with multiplication. We see that closed dot, okay? And same thing with division. Okay, we see the division symbol. Questions? Okay, so let's just go set up the first one here, okay? And you'll notice too on this one, it's got a -1 instead of an x, which is actually easier if it gives me a number instead of a variable, okay? And that's why we start off this way. So I see that this is a closed dot, which means multiplication, so I'm breaking it apart, okay? And here's what I've got. I've got f of -1, f comes first for this one, times g of -1. Are you with me? Does everybody understand how I broke those apart? Okay, that's what I'm evaluating now, okay? Do I know how to find f of -1? Isn't that what I literally just did up here? Yeah, okay, it's just that, okay? So that's what I'm going to do first. I'm going to go plug in -1 to f. How did I set that up? Where's f here? This guy? So we got 3 times -1 minus 5, right? Yeah? Yeah. Okay, what is that going to give me? 3 times -1 minus 5. So all I'm doing, I'm just doing f of -1. So I'm plugging -1 in to f right here. Okay? Yep, and what's that give me? -8, good. Okay? Do I know how to find g of -1? Same thing, right? But plugging into g. Let's go do it. What do we get when we evaluate that? If you can't do that in your head, that's okay. Type it in a calculator today, guys. What'd you say? Good, Jacoby. Yep, it is -5. Okay. If you were trying to do that without a calculator, it's just this, right? So it becomes, or sorry, I don't know why I put a 2 right there. Hold on. Whoops. There we go. So it becomes -2 plus -2 plus -1 gives me -5. Okay. So now I have f of -1, right? It's -8. I have g of -1. It's -5. What did this problem ask me to do? Yeah, multiply f of -1 times g of -1. What was f of -1? Negative 8 times, what was g of negative 1? And what is that? And I'm done, right? I can't do anything else with that. Was that bad? No. It looked really scary though. So just know, hey, I'm smarter than these Algebra 2 notations, okay? Don't let them freak you out. All right, working together. Looking at B, okay? It's very similar. What operation do we have on B? Subtraction. Okay, give you a couple minutes here. Try it out, try it out. First things first on B. I don't like this notation, so I always want to rewrite it in the better notation. And what does that look like? Good. F of 4 minus g of 4. If this would have been g minus f, well, then I'd have g of 4 minus f of 4, right? So just pay attention to that. Always keep it in the same order that it gives you, okay? But this one was f minus g. Love it, okay? Now what? F of 4. Which is? 7? Okay, we all agree that 12 minus 5 is 7? Yeah? Okay. And then g of 4. Seems like G is the one that's messing a lot of people up today. Just make sure we set it up correctly. Make sure we see that negative in the front, okay? If we write things down wrong, we're not going to get them right, okay? And what does that come out to?
Negative 25.
Negative 25? Do we all get negative 25? Yeah? Negative 2 times 16 plus 8 minus 1 gives me negative 25. And then lastly, I still have to find that final answer. And how do I do that? 7 minus what? Negative 25. And 2 negatives make a positive. So what is this answer? Positive 32. Love it. What questions do we have? It's not that bad? No? Okay. C. Help me out here. How would I write this in the better notation? Okay, yeah, this time it's x's, right? It's not a number. But yes, f of x plus g of x. You all staying with me? Okay. When I go to find f of x, right? Well, that's just an x. If I plug x in for x, is that going to change anything about f of x? No, it's just going to stay f of x, which is what? 3x minus 5. Okay, and then I have a, what is that guy? Plus sign, yep. And then g of x, what was it? Yes. What do you think I'm going to do with this? What'd you say? Combine like terms. Yes, okay? And that's really all I can do, right? Okay? That's it. This is not a solving one. I'm not going to go any further. I'm not going to factor. I'm not going to do anything crazy, okay? I'm literally going to combine like terms and be done, okay? This also, right here, gives me a little hint. It says to write them in descending order. So if I go by that, which term needs to come first?
Negative 2x is the second half.
Okay. Does he have a buddy? No. Okay. What comes next? Yeah. 5x, because 3x and 2x add to 5x. And last. Negative 6. And that's it? That's my answer? Are we okay with that? Okay. On D, I want you to real quick just try to set this up. Don't go any further yet, just because I want to make sure we set it up right before we do it. Also, this is a good time to just mention it's better for you to write your notes in pencil than pen. Every year I get people who just really love pens, and it just doesn't work out for them well. Okay, starting with our better notation. What am I writing? Yeah, f of x times g of x. Okay. You've already told me that f of x is 3x minus 5, right? And then we're multiplying. So I'm going to put this right here, but hold up a second. If I write it like that, do you think that's proper? Do you think that's how I should write it? Am I actually multiplying anything? Technically, if I write it like that, I'm really only multiplying negative 5 times negative 2x squared, right? What do you think would help me out here? Parentheses. Around what?
Around 3x minus 5 and
Yeah.
another problem.
Oh, and now do we see what's about to happen here?
I like this.
Your favorite F word that we just talked about in the warm-up? Uh-huh. Yeah. Foiling, okay? Great question. How are we supposed to FOIL if one of these has 3 terms? Okay, it works the same way. Okay, the first term times the first term. Every term has to go to every term. Okay, so we'll go slow. We'll do this one together. 3x times negative 2x squared. What is that going to be? Negative 6x cubed. Good. All right. 3x times 2x. 6x squared. Yep. Remember, we're adding the powers, right? This is so gross. Oh my gosh. It's going to be in the video. It's going to be recorded for years to come. Okay. 3x times negative 1. Negative 3x. Okay. Great news. We're halfway done, right? This first term has gone to everything. Now I just need to distribute that negative 5 to everything. Negative 5 times negative 2x squared. 10x squared. Negative 5 times 2x. Negative 10x. And negative 5 times negative 1. Plus 5. Okay. And then what can be done?
Combine like terms.
Combine like terms. Do you have a question?
Oh, no.
No, you were telling me what to
Yeah.
do. Okay, sorry.
No, you're
All
How
right.
Cube, actually.
Cube. What's he do?
He's alone.
He's alone. He stays in the front. He has no friends. Dang. Sad. Okay. After that. 16x squared.
He decided this is the staple. This is his fault.
Okay, then what?
Minus 13x.
Minus 13x. And last but not least, plus 5. Does he have any buddies?
No, he's alone.
He's alone like Jacoby. You are a terrible friend. That's awful.
So mean.
Okay, don't be mean to my friend Jacoby. Okay. All right. Any questions on this? Really quickly, really quickly. You don't even have to write this down. I just need you to pay attention and remember it. Okay? Real quick. Eyes up on the board. Okay? One thing that's not in these notes that used to be in my old notes. Okay? And I probably need to add it in here. Okay? What would happen if, we'll just stick with f minus g, or sorry, with f and g. What if I had f minus g of x? It'd be the same thing as what we have going on up here, right? F of x minus g of x, okay? So I would have 3x minus 5. I would put my minus sign. And then here is my g of x. And do you see what I need? Hopefully you see what I need. What do I need? I do, but around what? Do I need it around both? No, just the g, okay? I could put it around the f. It wouldn't really matter. But if I, just like up here, I was multiplying the whole f by the whole g, right? So I had to put these in parentheses so that way every single term got multiplied. Down here, I'm subtracting f minus the whole g, right? The whole thing has to get subtracted. If I don't put parentheses up, technically the only thing getting subtracted is the first term, okay? If I put these parentheses up, now all of a sudden I'm distributing out -1. Every single term got subtracted just like it was supposed to, okay? Does that make sense? You're going to see that. That's going to be on this test, I promise, okay? So make sure If we want to write that down, we can. But again, this would be the same thing. It'd be combining like terms, but just make sure you distribute that -1 first, okay? Any questions? All right, last thing. I know you're getting antsy, okay, but we're almost done. Last thing, and again, this is a weird one, okay? I don't really like these, but it's part of Algebra 2. Biggest thing here, I'm giving it to you, or the EOC is giving it to you in an ugly notation. You've got to be smarter than the notation. You've got to know how to write it better, okay? So when I see something that looks like this, okay? This dot is not a closed dot. This is an open dot, okay? Closed dot means multiplication. Open dot means of in math, okay? Of, okay? Of is not multiplication, okay? Instead, it is a composite function is what we call them, okay? How the notation it's going to get, or what the notation is that they're going to give you, it's going to look like this, okay? This kind of looks like the word fog of x, okay? You've got to write it in the better notation, which is this right here, okay? F parentheses g of x in the middle, okay? Always keep it in the same order though. So on this one, it's f of g is how I say that, okay? F stays on the outside, g goes on the inside. If I come down here, I've got g of f of x. That's how I would say that, okay? G would stay in the front, then f of x on the inside. For my visual people, let me write this a little clearer, okay? We've got f of x, we've got g of x, right? Okay. F of g, I've got f on the outside with g of x on the inside. Okay. G of f, I've got g on the outside, I've got f of x on the inside. And here's the biggest thing I need you to remember about this. Work from the inside out. Work inside to out. Write that down. Please write that down. Do not forget that, okay? These are not as scary as they look.
So if G's in the middle, you would work on G.
Yep, so we're about to do that. Yep, so hold up. I'm getting ahead of me. You're okay. I like it. Looking at A, okay? F of G of -2. So the first thing I got to do, I've got to write it in the better notation, okay? Which letter comes first? F. He's on the outside then. Okay? So that means G of what? -2 is on the inside. And I am working from the inside out. Okay? So if I look at the inside, it's just G of -2. Do I know how to do that? Absolutely I do. Okay? We've been doing that all day. So I'm going to go find out what G of -2 is. Go plug it in. Just like before. Okay? What is it? Make sure we're writing this down. What is G of -2 going to be when I evaluate this? My calculator will do it for me, or I could do it in my head. If your calculator, you feel like it's not giving you right answers today, let me know and I can show you how to type this in. What do you get? I got -13 too. Awesome. Okay, so what you're telling me then, guys, you're telling me that G of -2 equals -13. We just found G of -2, so don't you think I could replace G of -2 with -13? So now what this question is asking me is what is F of -13, right? Okay, I'm just drawing an arrow. You don't have to draw that, but I'm just drawing it so that way you realize that's where I got that, okay? Do you know how to find F of -13? Yes, I can see the light bulbs going off right now.
So is that
Okay?
That's all we do?
That's all we have to do, yep, once we find it. Okay, can you help me find it? What do I do now? 3 times negative 13. Are you with me? Minus 5, right? Yeah?
Yeah.
I was talking to him, but he was zoned out. It's okay. I zone out sometimes too. Okay. What is that going to be? I didn't hear that. What? Negative 44. Is that what we all got? Yay! Box it in, box it in, box it in. Get in the habit of boxing in your answers in this class. It helps me when I'm grading. Thank you. All right. I want you to go do B with your group. Go try B. Pay attention though. It's G of F, not F of G. Set it up for me. First off, we write it in the better notation, right? We don't like this notation. It's scary. What's the better one?
G in parentheses, F in parentheses 4.
Cool. And now what am I doing?
F of 4.
Okay, F of 4 first. Which is 7. And now I'm finding...
7.
And how do I set that up?
It's gonna be shaped up and
Minus what?
1.
Oh,
Yeah.
1?
Yeah.
Okay. All right, now what? It equals negative 85? Is that what we all got, was negative 85? Yes. Is that what I got? Good job. All right, any questions on those? All righty, friends. We got to lock in. We've got one more question, okay? This is a tough one. We saved this for last. It's a grand finale. Don't let this question make you drop honors algebra 1, or algebra 2, I mean, okay? It's going to be okay. It's really not that bad. It's just, it looks bad, okay? All right. First off, help me set it up. G on the outside. Okay, so you're telling me f of x is in the inside. Okay. So, again, it's the same process here. Okay, I'm plugging in what I know f of x to be. Do I know what f of x is? Yeah, it's 3x minus 5. Okay, this time it's not just a number that I'm evaluating, right? It is a binomial. Ooh, fun. Gentlemen, you with me right now? Okay. So, now I'm finding g of 3x minus 5. Okay, what do you think I'm going to do? Dun, dun, dun. Well, what did I do when I plugged in g of 7? I just put 7 in where? Where I saw x. So what do you think instead of 7, I'm going to put where I see x?
3x minus 5.
Yeah, I sure am. Okay, this is so fun. All right, this is definitely going to make Ava want to be a math teacher when she grows up. Okay, here we go. We got negative 2. And then in parentheses, we've got 3x minus 5, right? With what on it? Squared. Plus 2 with parentheses. 3x minus 5. And then that. This is gross. Okay. Hold up a second. Friends. Before we just start attacking this, okay? Order of operations. What do I have to do first? Which means what? What did we learn in the warm-up today? A binomial squared. What does it mean? You got to multiply it by itself. Okay, so what you're telling me then is that this should look like this when I expand it. This is not the class to have first hour. We're having some regrets, okay? It's okay. We're almost done. This is all we got to do. We just got to get through it, okay? Here's the thing I need you to remember, though, okay? In case you don't remember this from Algebra 1, gentlemen, okay? Multiplication follows what we call the commutative property, right? Meaning I can multiply in any order. 2 times 3 is 6. 3 times 2 is 6, right? Okay? So when I see something like this, what I have here going on in the beginning, I could go ahead. This is probably what I'm going to do. I'm going to multiply the negative 2 times this first set of parentheses. Take that answer and FOIL it with this other 3x minus 5, okay? Or I could FOIL both of these 3x minus 5s and then distribute the negative 2 into that, okay? However, here's what you can't do and what I see people do time and time again. This negative 2 is only in front of this first set of parentheses, correct? So do not distribute this negative 2 to both sets of parentheses. That is not correct. That's not a thing, okay? So just make sure that you multiply everything once, okay? So here's what I'm going to do, and I'm going to do it kind of quickly just because I want to get this over with. Negative 2 times 3x gives me negative 6x. Negative 2 times negative 5 gives me 10. And that's what I'm going to FOIL with this next 3x minus 5. Okay, so the first thing I'm doing, negative 6x times 3x. Negative 18x squared. Negative 6x times negative 5, bless you. 30x. 10 times 3x. And 10 times negative 5. Okay, and then 2 gets distributed over here. That gives me 6x minus 10 minus 1. And now what?
Combine like terms.
Yep. Okay, so starting with my biggest exponent, does negative 18x squared have a buddy? No. Don't you dare call him Jacoby.
66x.
Okay, 66x. And lastly, minus 61. Am I done? Oh, you are. You are. Okay. What questions do we have on this? Was that bad? No. It was time consuming. Okay. All right, your homework is posted.